Yeah, so a little quickie on my history. I came from industrial automation space, and I'm relatively new to Red Hat. I was a Rockwell automation guy for the last 20 some years, so I'm very good with workspace. And today I want to talk a little bit about where we see the market going and ecosystem going, and how Red Hat plays into that with CODESYS. Um, So primarily, we're going to talk to you today a little bit about a new industrial control platform. And this is a joint venture partnership arrangement between Intel, Red Hat, and CODESYS is involved in this as well. And the concept here is providing a platform that's scalable, allows best in breed, breaks a lot of those challenges that a lot of our industrial customers have today, and solve a lot of those major challenges. It aligns very heavily with Industry 4.0, Namur. I don't know how many people are here are OPAF familiar, but Open Process Automation Forum as well. So those technologies are really where what we're actually trying to talk about here in the next few slides. So quick, I'd just like to touch a little bit about some of the problem statements that's really driving the transition. And we really think we're on the cusp of a major pivot from proprietary hardware controls to more of a software-driven solution. Much like one of the major reasons that we picked CODESYS as a primary partner in this space is because CODESYS is already down that road for quite a while, and they've already realized that transition. And it's a big challenge for a lot of the major industrial automation players to try to get down that road. But there's a big market push for that. And some of the drivers here, interoperability between hardware, fixed proprietary devices. Interesting thing Lars mentioned in the last one, he talked about, safety being, software driven. And when you look at, a PLC or a controller or a DCS, at the end of the day, what makes it a process controller or a motion controller or a safety controller, or discrete controller or whatever, what makes it that at the end of the day isn't really the hardware necessarily. It's really more the actual software and application that you put upon it. So it makes total sense to decouple a lot of the hardware from the software so that end users don't get stuck into that mold where they have to keep upgrading hardware. They have hardware restrictions and things tied to various proprietary hardware that doesn't have a lot of flexibility, doesn't allow simple upgrades, becomes obsolete, and it's not a simple matter of just finding an off-the-shelf piece of hardware in those spaces. So we see a lot of that market driving in that space. Clearly, downtime has always been an issue. Doing updates and software updates and managing cybersecurity realm. And doing that live and with real-time content is challenging in today's infrastructure. And it's a very costly adventure where with modern technologies, a lot of the software stuff we're doing today, makes that much simpler and easier to do. I see a lot of pressure on users to develop content that's more productive without adding more resources, without adding more people. Having a software solution allows a lot more flexibility for interfaces to AI and interfaces to higher level systems to make some of that productivity pushes that are happening in industrial space easier to deploy and easier to maintain and get it going. Plus, we see a big learning curve challenge in the PLC market. A lot of the guys coming out of college, are not, PLC ladder programmers. They know higher level languages, they know tools, but not necessarily the stuff that we're all used to in this market. So, trying to reduce that learning curve is also a big player in this space. And we see these as drivers to really push what we see as a major transition of the market from proprietary hardware to open soft solutions. This next slide I stole from the OPAF, the Open Process Automation Forum group. And this really talks about sort of the ecosystem and the architecture. And bottom red box down there, they have these things called DCNs, and those are distributed control. Think of those as PLCs, very similar to what we have today. Those could be hard PLCs. They could also be virtual ones or containerized ones like we just talked about. And we're going to talk through where we are today, or Red Hat is today with Intel and CODESYS in that space. And also, we're going to talk a little bit about that other box with the red circle on it, that advanced computer platform. And that's taking sort of the containerization content that Lars sort of talked about, having a containerized control, and taking that above an IPC, embedding multiple instances of those and managing multiple instances of those on an advanced compute platform to give you an easier scale, lower cost solution, and potentially a lot better performance in that space. They also have some other ideas on this slide. There's some virtual DCNs, running in the cloud, running in other platforms. I don't know that the market's quite ready for a cloud-based PLC yet, but it's coming, and the content that we're going to talk about in this slide and on this platform kind of enables that capability if we get there. I'm going to give a quick overview of Red Hat because many of you on this call don't know Red Hat and don't have that understanding of what Red Hat's role is in this space. Red Hat is a major player when it comes to Linux distribution. We have open source Linux solution that we provide. More than 90% of the Fortune 500 companies rely on Red Hat products today to do their deployments, to do their content. A lot of the industrials are using this already in their IT departments and other space. Commercial banks, telecoms, healthcare, government, military. We have a very large footprint, and a lot of the customers that are using PLCs today, we don't have as big a footprint lower down the stack on that PLC space, and that's where we're headed now. As more of a software-driven solution becomes more popular, we have that capability to push down that and bring our technologies on there. Our technologies, I really want to point out, one of the biggest obstacles that we're seeing in the market is a lot of the bigger end users are worried about being, first, version 1.0 of a solution or a platform. The good news is Red Hat's been around a long time. This is not new technology for us. The stuff we're going to talk about has been deployed in a lot of different environments, just not as much in the industrial space. And we think it's got a good footprint there along with Intel and what we're doing with CODESYS. So if we look at the portfolio of products that Red Hat provides that make sense in this space, obviously Red Hat Enterprise Linux is our core platform. That's our Linux distribution, 10-year life cycle, which is unique in the market. A large tool chain. It has a Kubernetes management stack called OpenShift that makes that containerization, managing all of that containerization that Lars talked about, simpler and easier to handle and manage. We released recently in the last year or so a product called the Red Hat Device Edge. And Device Edge is a lighter weight version of that enterprise class Linux that we talk about. It's made for smaller footprints, for smaller single core devices where it can run at those lower layers, down at layer 1, layer 2 in the control environment. So we have a product line that goes down to that layer as well as the container management software. We have a product that's an OpenShift derivative called MicroShift, which also runs in that platform to get us down onto that lower scale for easy deployment on single IPCs. And then on the right side of this slide, there's something called Ansible Automation Platform. And many of us, the IT departments, manage our laptop source and patch our software and upgrade and update and make sure things are running smoothly and restart services that have failed. Ansible Platform is the Red Hat platform that many IT departments use today to do that kind of work. That same platform can manage all layers of the OT environment as well. To make sure that systems stay current, policies are enforced, safety and security patches are all in place, network interfaces. one of the interesting things in the OT world now that Ethernet is very heavily used on OT platforms. Um, how many of your maintenance guys at 3 a.m. know how to reconfigure a layer 2 Cisco switch when it fails or gets run over by a forklift truck at 2 in the morning? So a product like Ansible can automate a lot of that maintenance and deliver that content very easily up the stack. So let's talk a little now about the partnership with CODESYS and Intel and the platform that we're actually building together. This platform is really based on sort of a three-stack layer. We have a hardware layer driven by Intel with a lot of tool sets like cache allocation and a data plane development kits, time service, time sensitive networking, so TSN capabilities, those kind of things built into the hardware layer. And by working with RedHat to make the operating system align very cleanly with that architecture and easily adopt those technologies into the software stack, it makes it easy for us to work with CODESYS to actually use those tools to provide a very performant, very stable, very OT ready platform. That little table in the top right up there, it's intentionally an eye chart there. That's really some of the performance testing we've done. So the RedHat platform is a real-time platform. So performance in this space, we have microsecond jitter potential there in that area that we're showing in that graph. There's a white paper out there. You can take a look at it if you want to see what those performance numbers look like and how we've developed with CODESYS a platform that can run this architecture very seamlessly at a very performant level with the containerization that Lars sort of talked about. I do like to talk a little bit about the maturity model of customers who are first going into this space with us or going into this space in general. By far the prevalent PLC, market is driven by hardware PLCs, like dedicated solutions. We see that changing. And as that changes, we've been working with a lot of the big end users, a lot of the big customers to help them through that hurdle on the next layer. What we see in the maturity model, however, is, okay, we're all engineers here. We all love to go play, build something, make it work. And those first adopters, that first time you're doing it, people go by, go get the Ubuntu, go get the Debian builds, get that content in place. It's easy to get, it's easy to deploy. You get, you get to learn quickly and grow in that space very fast. But what they find after a deployment and after a year or two, there's a lot of management layers that go along with that for non-enterprise ready solutions that makes that a little bit more challenging to keep it running, keep it maintained. It starts consuming a lot of your engineering time on just worrying about, do all the tool chain that works with this operating system still work in the new version when I patch it? Do I have to build my own patches and build my own content to know when I have to patch? All of that content, really drives to an enterprise ready solution, which is where RedHat kind of shines in that space with CODESYS to make sure that the platform itself under the hood is healthy and alive and stays current without spending a lot of your engineering time on it. Because your engineering time, let's face it, should be focused on production. It should be focused on improving the application or improving productivity or reducing downtime, not on patching and building patches and making sure that a certificate tool chain still works in the latest operating system, right? So that's when an enterprise scale tends to come in. So we see a lot of first-time deployers playing with the stuff, getting stuff out there, learning a lot, and then jumping over to a more enterprise-ready platform as things move on. And this unified platform, again, consistent management, having a common platform up and down the stack, from the control layer with CODESYS, their HMI running on that platform, all the way up to higher level systems, provides the customer with a seamless architecture that they can train people up on working and train people up on how to do without having to retrain a lot of people. And honestly, that initial slide I showed, 90% of Fortune 500 companies already have RedHat products in their facilities, already have the skill sets, maybe in their IT departments, but still have those skill sets in-house that can help keep this stuff stable and working seamlessly without having to retrain a lot of people in that space anywhere in the stack, which is why that's super advantageous. So when I look at the stack or sort of the different layers here that we're talking about, the device layer, instrumentation, IO, those kinds of things, the control layer where CODESYS plays heavily right now. And then there's this other concept of an advanced compute platform. So today, the white paper I talked about with the performance numbers, the work we're doing with Intel on, locking cache in and all the other content we're doing to get the performance where we need it and the special tuning to get the operating system and the hardware and the runtime code execution working seamlessly together is all of that second stack there, that PLC DCS layer for providing control. I want to talk to you a little bit about this advanced compute platform and something that CODESYS and Red Hat and Intel are working on right now. And I expect sometime in the next year to start releasing something early in 2025, some more white papers and documentation on how to actually run control at a higher level into advanced compute platforms onto a server class machine instead of just on an ICP. A lot of what that provides you with is it provides you with, more flexibility in hardware, a lower cost solution. Now you can run multiples of those containers, many of those control containers on a single ACP, providing that scale and that cost reduction. Better growth, better scaling. So if you need more memory and more horsepower, it's much easier to do it on a product like that than it is to do it on a single IPC when it starts cascading across the width of the plant. Other great thing in this space is being able to run other tools in that same piece of hardware. So digital twins, virtualization, virtualized workloads, all of that can run on that same ACP, reducing again the cost of maintenance challenges and a lot of that in that space too. So I'm very excited about this moving forward, being where the market's going and where we see us excelling with CODESYS and Intel. When we talk about some of the flexibility that this provides, that a solution like this provides, obviously things were built for security. So cybersecurity is just built into the operating system, into the hardware, and designed initially right into the architecture. So security is kind of built in by design. Maintenance, that product we talked about, Ansible, and container management and managing the Kubernetes stack, all of that is built into the operating system and into the platform for you. A lot of flexibility with what workloads you're running. Scalability, again, I talked about how it can grow and easily expand. I want to make a quick comment here too about the relationship of Intel and CODESYS and Red Hat together as a partner. One of the things that Intel and Red Hat are very sensitive to and want to make sure we drive, we are not controls people. We do not, our objective is not to make the new generation controller, and drive that entire industry. There's people like CODESYS here and our partner, which is why we partner with CODESYS, that have that expertise to build the design, the runtime, to design make the design time for their applications that people are used to doing. We have no intentions of becoming, control creators. We have intentions of working with customer like CODESYS as a partner to make sure we have a stable platform that makes this architecture seamless and easier to deliver. To give one of the great things about a hard PLC, you can plug in a hard PLC and it just works. With a soft PLC, there's configuration and setup that needs to be done to make that same experience. We want to make that simple, and that simple with a partnership here in this space. So to just do a quick summary of I know I went through a lot of stuff really quick, but this partnership, between Intel, CODESYS, and Red Hat is really driving around, getting a hardware independent platform in place with a diverse tool chain. And I didn't talk a lot about the tool chain that comes with the operating system, that comes with the Kubernetes stack with OpenShift. But those tool chains are extremely challenging to maintain over the life cycle of a product. So, Red Hat takes care of a lot of that work for you in this architecture. OS longevity, 10-year life cycle on the platform, so the platform, can keep running without you having to worry about constantly having to get to the latest revs. Real-time performance, There's a white paper out there I mentioned, and I had that link in that slide to talk about how, where our real-time performance numbers really are in the space. And we hope to have that for the ACP here in the early next year. Automated management, taking that burden off of your engineers from having to figure out how to patch an open source solution, and having the Red Hat provide that for you out of the box, as well as it being enterprise ready. So something that your enterprise already knows how to use, and has the stability and reliability and the experience of running in industrial spaces as an enterprise ready platform. Okay, that was my discussion. I think I made it in under time, so nicely done. Thanks.